Okay, so here's video 2 for our 8-4 notes day 1. We're going to be looking at example 1, so if you're following along in your textbook, that's not going to be very helpful now because a lot of the graphs in your textbook have a lot more unique shapes, and we just want to focus on some of these more common ones. So here's the example that I have for you. We want to start by finding and plotting our asymptotes. So we have vertical asymptote is always what makes your denominator 0. So we set that equal to 0 whether you factor or take square roots. We get with plus or minus 1. So the first thing I did on this graph was draw my dashed line at x equals 1 and x equals negative 1. The horizontal asymptote depends on our scenario here. So we have our 3 rules. We need to choose which one we have. Here we have a degree of 3 over a degree of 2. That means our numerator's degree is bigger than our denominator's degree, so there is going to be no horizontal asymptote for this particular graph. So we have no horizontal line to sketch. And then at this point, we just do a table of values. So like I said on yesterday's videos, you want to start with whatever values your graphs go to. The values on your worksheet for tonight and tomorrow are going to go between -7 and +7, so that's why my table might look a lot larger than yours. I did spend a little more time writing down every single value in between there, unlike yesterday, just because these do have a much more unique shape, and I want to make sure that my graphs are as exact as I can. So I just went through and I plugged in every value between -7 and +7, except for obviously 1 and -1, because we already stated that those are going to be your asymptotes. This graph isn't truly symmetrical, but there are some symmetrical properties. We have a small parabola on the inside, and then we have 2 branches on the outside. And what you might notice here is there's an oblique asymptote. Even though we're not using that approach to set up our graph, we can see that because your numerator was 1 degree more than your denominator, that has the potential of happening. Okay. If you're not sure how many points to plot for these, you want to plot a ton. There's only 4 problems on tonight and 4 problems on the next worksheets. So take your time to plot these in your calculator. And you want to be very careful when you plot these or type these into your calculator because you could have the potential of typing them in incorrectly. So I'm going to grab my calculator for you and show you this one. So for this particular case, we want to start with the numerator in parentheses and the denominator in parentheses since we do have multiple terms in both. So let's say we want to do -7. So I'm going to do -7 in parentheses, but the reason why I have that separate set of parentheses open is because I'm going to group my whole numerator in parentheses. Like so. Oops, I forgot the 2 to the 3rd. -2. So that entire expression is just the numerator. Divided by, open your parentheses, -7 squared minus 1, close your parentheses. So I kept my -7s in parentheses because I always want to put negatives in parentheses, especially when I'm dealing with exponents. And then I put my numerator and my denominator in parentheses, and there's my value. Okay. All right. That's going to wrap up. Actually, let's see. I do have some additional notes down here. Oh, I extended my graph a little bit because I was a little unsure what's happening here at this hump. If you're not sure if you're supposed to go up or down, you can plot half values. So I actually went back and plotted in half values. Now, for the sake of these lessons, I'm not expecting you to plot a ton of decimals. That would be something I'd advise you do on quizzes and tests. Once you have a general idea of what your shape's going to look like, then you'd probably have enough points plotted. If you can't quite figure out what your end behavior is, then you want to plug in more values. Okay, that wraps up example 1.